Hello everyone, it's Asatya Games. Today I will show you how you can create a first-person controller with Defold. At the end of this tutorial, you will have a game like this, where we will be able to look around, move, and as you can see, we have step functionality where camera gives the impression of walking by oscillating up and down. We can interact with objects and we can run. I also have this skybox, which was the topic of the previous tutorial. So if you want to implement the skybox, you can watch that tutorial. I will not explain how you can set it up in this tutorial. Now for starters, right click to the project folder, new folder, and name it player. On our player folder, we will have a collection. So for this, right click, new collection, and name it player. We will not create a game object, but create a collection, because when you create a game object, you cannot have another game object under it, but with a collection, you can have as many game objects as you want. So for this, on the player collection, right click, add game object, name it body. On it we will have two things. One is the collision object and the other is our script. I will explain the scripts in a bit. For the collision object, right click on the body game object, add component, select collision object. On it, set the type to dynamic. We will have locked rotation. Our player will be on the player group. For the mask, we will have default and ground. Group is where you are at, and our player will be in the player group. You can have only one group. For the mask, you can have many of them, and these are the groups our player will interact with. After that, on the collection, again add a game object. This time name it camera. On the camera, right click, add component, and select camera. We will not change anything on the camera. Now we have two scripts. For this, on the player folder, right click, new script, and name it camera controller, like this one. Let me explain what this camera controller does. On the script, we first have a bunch of properties. The first property is rotation speed. This is how fast the camera will rotate when you move the mouse. We have player ID, which is the body of our player. This is our player body. It is a capsule. We don't have a model because on the first person you don't need to have a model or animations. And we have camera height, which is 2.5. That means our camera will be placed half unit above the player. We have two properties for the steps. First one is step frequency, which is 3, and then we have the step amplitude, which is 0.3. This is how high and low the camera will go when walking. Then we have a local variable named pointer, and it requires the pointer module. As you can see, we have a pointer module here. If you want to create a module, right click, new Lua module, and name it pointer. This is a module I have found on Defold forums, and it basically allows you to lock or unlock the mouse, and we will use this pointer for this purpose. We have a minimum X and maximum X rotations, and this limits the camera when we are looking up and down. We have our init function, and on it we first acquire input focus, so our camera will be able to detect key and mouse inputs. On our self table, we create a bunch of variables. First is y rotation and then x rotation. We set them to 0 at first. We create a current y and x rotation values and set them as the y and x rotation, which are 0. We set pointer.locked value to false, means when you start the game your mouse will not be locked, but we set the request lock to true, so we will start as our mouse isn't locked, but we will be locking it. So if I comment this out and play the game, you will see that my mouse isn't locked because I am not requesting a lock. But if I take this back and play the game, my mouse will be locked. We set the step timer to 0 and set the step offset as an empty vector. After int, let's go to the onInput function. We have 3 checks here. First, we check if we have pressed escape. Let me show you my input binding file. I have inputs here. You can press the plus and select the key here and give it a name. You can do the same with the mouse triggers. And if I press escape and I just released it, means when you press the key once, it will be called only once. If you don't add this part, it may be called more than once because you are likely to press the key during more than one frame. We use escape to unlock the mouse. It is locked right now, but if I want to be able to close the game, I will press escape, unlock the mouse and close it. So with this, when we press the escape, we set the request lock to false, so we will not autolog this on the update. We set the locked value on the pointer module to false, and we use window.setMouseLock to false to unlock the mouse, and we return. If we left click with the mouse, again we use this to call the inner part only once, and our pointer isn't locked. That means we are unlocked right now, which is here, and if I left click, as you can see, we will be locked in. So we set the request lock to true to lock this on the update, and we return. Lastly, we check for the mouse movement, but only when mouse is locked. So if our mouse is locked and the action has dx and dy values, dx and dy are basically delta values and shows how much the mouse has moved in the x dimension, and same with the y dimension. You will only have these values for mouse inputs because when you press a key, it's not a movement input. So with this, we know this is a mouse movement input. We need to use these values to control our camera. So we set the y rotation and x rotation to their new values. For the y rotation, we decrease the x value and multiply it by the rotation speed. For the x rotation, we basically do the same, but add the value this time. We also use this line to limit the x rotation between the minimum and maximum rotations. This math.min will return the smaller value between two, so you will never get a value greater than maximum, because if this is greater than maximum, that means the minimum will return the max, and we do the same with the minimum to limit the value. Since we updated the values on the onInput function, now we can use them on the update function. On the update, we first update the log state on the pointer module, and then we have a check here. We check if our pointer isn't locked, but we are requesting it to be locked. That means we have pressed escape to unlock the mouse, but we want to lock it back. We use window.setMouseLock with true to lock the mouse. We have the current Y rotation and X rotation values, and we will be using a vector met.lerp to smoothly transition them from their current values to the Y rotation and X rotation we have set on the onInput function. You can just use these values too, but then there won't be no smoothing. So to give it a smoothing effect, we have created these variables. We lerp between values, and this value is how fast it is going to be lerp. If you put 1 here, it will be instant movement, but if you put a very small number here and try to play the game, you will have this effect where it smooths very slowly. Now we create two local variables, QY rotation and QX rotation. Q stands for quaternion. We use vector met quaternion rotation Y with the QY rotation, and for it we get our current Y rotation but convert it into a radian value. To be able to use it with this vector, we do the same with the X, and we use these values to get our camera rotation by multiplying them. Then we set the camera rotation using GameObject.setRotation. Now we create another local variable named player position and get the position from our player ID, which is the position of our body. Then create another local variable named base camera position, and our camera will be placed where our player is, but we will also lift it by camera height value, so we will not look from our feet. If you don't add this part and play the game, you will see that you are actually on the ground. We get our velocity from our collision object using GameObject.get, and we get the linear velocity. We calculate the horizontal speed by taking the square of x and z values. Then we take the square root of them to get the horizontal speed. This basically gets the hypotenuse of the speed. Now here, if you don't want to use the step effect, you can just remove this part and continue with these two lines, and you can of course remove this part. But I think the step effect gives a more polished feel to the game, so we will keep it. We create a step target vector, and we check if our horizontal speed is greater than 0.1, which means we are moving. Then we increase our step timer by delta times the frequency and also the square root of our horizontal speed. You can use just horizontal speed here too, but then if you increase your speed by 3 times, then the camera will also move up and down 3 times faster, and it doesn't look very good. So we will take the square root of it to lessen the effect of the speed on the oscillation. On our step target, we set the y value using the sine function on the mat, and For the value, we use our step timer. Since sign goes up and down, it will give you the desired walk effect. Since this will return a value between -1 and 1, we will multiply it by the amplitude to get the correct height we want to apply. This is the step effect if we are walking, but if we are not, if our horizontal speed is smaller than 0.1, then what we need to do is to reset the camera offset. So we use vector mat.lerp on the step offset and we lerp it towards a vector 0. With this, let's say I stop when camera is up. As you can see, camera moves downward and you will not have a camera stuck at the top because you have stopped there. Now for the step offset, we again use lerp from the vector mat to have a smooth transition between our value to the target value. This time I used 0.25, but you can use 0.15 or any other value you want. Lastly, on this script, we use GameObject.setPosition to set the position of the camera using the base camera position we have calculated here, plus the step offset to give the illusion of the walking. We also set the rotation of our player, which probably isn't that necessary because we don't have a model, but if you want to use a model to see the hands of the model, then you will also need this line. And this was the camera controller script. Now we have our player controller script. On it we create a bunch of properties. We have our move speed and jump force. We have the raycast length. We will use this to detect the ground. And we have some ground groups. If you remember, we have our mask where we detect grounds, default and ground. We also have them here. So when we are on them, we will know we are actually on a ground, so we will be able to jump. I have my movement keys, a key to run and jump. For the direction object, I get the URL of the camera, and we have a rotation smooth speed, which isn't necessary because we don't have a model here. This script was from the third person controller script. I have modified it a bit, so that was an unnecessary line. We will have some local variables, grounded, jump timer and raycast groups. On the init, we will acquire input focus, so player will know when we press key. We create an input table on our self table, and it has x and z values for horizontal movement. We have a jump value and run value. We have our empty table raycast groups, and we use get raycast groups to save the groups we will be using. This will get the groups we have, and here we check for ground group 1 and 2. You can populate this more as you like, and we check if these values are set. If you delete a value from here and play the game, the player will not detect that group as ground, so you will not be able to jump on them. I have deleted the group where boxes are, so if I delete them and try to jump on them, as I am doing right now, you won't be able to jump. But if you have them and use it on the box, I can still jump on the box because the game will know this is a group I will be using for the ground. We have an is grounded function. On this function, we first get our position using GameObject.getPosition. If you don't enter a URL here, it will get the position of the game object this script is attached to. Since we will attach this script to our body game object, it will get the position of the body. While I am here, let me show you how you can attach the script. On a game object, right click, add a component file and select the script you want to attach. We have a y offset value. This value will be used when we are raycasting, and we will start with an offset from our position. As you can see, our position is at our feet, and if we start raycasting from here, it is possible to miss the ground, so we will give it some offset for the raycast. And since we will be using 0.35 for the raycast length, we will have a 0.15 length below the player to detect the ground. We create a vector named down, and it is basically a vector pointing downwards with the length of raycast length. Create a hit variable and set it false at first. We also have a radius value. This value will be used when we are creating more points. As you can see, we have an offsets table, and on it we have a bunch of vectors. These vectors will give us points on our player, but with some offset. So our main raycast will be made from the center, but we will also use some offsets to check around the player within a radius. We do this so when we are standing on the edge of an object like this, we will still be able to jump, even though our center raycast isn't colliding with the ground. Since we have our offsets, we use for loop to iterate through them. On the iteration, we create a from vector. For it, we use our position plus offset, where the ray will be cast. And we have a 2, which is basically a vector starting from this vector and pointing downwards by the down vector. For the result, we use physics.raycast and start from the from vector to the to vector, not the best choice of the names. And for the groups, we need to consider for a hit, we use raycast groups we have set at the beginning. If we get a proper result, and the result.normal.y value is greater than 0.1, which means we are on a flat surface, then we set the hit value to true and break to end the loop, because we don't need to check anymore, we are on a ground. Then we return the hit. If this condition is met, then we return true. Otherwise, we return the false value we have set at the beginning. On our on input function, we check for the key inputs. If the action ID is key forward, which was W, then we will set the Z value on the input table either to 0 or -1. If we have just released the key, then we will set it to 0 because we don't want to move anymore. If not, if we are still pressing it, then we set it to -1. We do the same with the S key for the backboard, and if it is pressed, we set the Z value to 1. If not, it is set to 0. Do the same for the left and right. This time set the X value to -1 or 1. If the action is run key, which was left shift, we set the run value to not action released. If you have released the action, this will be true. So not true will be false. That means run value will be false. So when you stop pressing the shift key, run value will be set to false. Otherwise, if you are pressing the key, this will be set to true. We do the same with the jump, but we also check for being grounded. So if you press the jump key and you are grounded, that means you can jump. So we check action that pressed is true. So we will set this part to true only once. On the update, we have two functionality, jump and movement. We first update the grounded variable using the isGrounded function. We get our velocity using GameObject.get from our collision object and get the linear velocity. If we are grounded, we don't need it right now. If we are grounded, we check if our jump input is true and our jump timer is less than or equal to 0. That means we can jump. Right after we jump, we set the jump timer to 0.2. So on the next frame, even if this jump value is still true, unless 0.2 second has passed, then due to this check, you will not be able to jump again and set your velocity on air. When jumping, we set our y velocity to jump force. This will make us move upward, and we set the jump input to false because it has done its job and we are jumping. And here we decrease the jump timer by delta, so this 0.2 value will eventually hit 0, and next time when we want to jump, we will be able to. Here we have our movement logic. We create x and z values and get them from our input table. We create a vector using these values, and if the length of the direction is greater than 0, we normalize it. Otherwise, when you are pressing two keys like up and right, your player will move faster diagonally. We have normalized it here. If the length of it is greater than 0, that means we need to move. We get the Y rotation from our camera, and we use GameObject.get on the direction object, which was the camera, and we get Euler.y, and we convert it to radians using math.radian. We create a camera quaternion value and use vector math dot quaternion rotation y with the camera y rotation. And lastly, we rotate our direction with the camera quaternion value to get our new direction. This line ensures when you press W, you will not always move to the north, but will move towards where your camera is pointing at. We create a variable for spell multiplication. If our run value is true, which means we are pressing left shift, then we set this variable's value to 3. If not, we set it to 1. And since when we calculate our speed, we use move speed and this multiplication value. If you are pressing run and it is set to 3, then you will move 3 times faster. We set our velocities x and z values using the x and z values from the direction vector. We multiply it by speed. We call physics.wakeup to wake up the physics to apply the change we have made on the velocity on the collision object, and the physics engine will handle its interaction with the environment. If the length of our direction isn't greater than 0, That means we aren't pressing any movement keys, so we set our velocity x and z values to 0. Lastly, we set the linear velocity on our collision object with the velocity value we have modified. And these are for the scripts. On your main collection, you can right click, add collection file, and select the player collection to add the player to your game. Now I have a bunch of objects here. I have a box, I have a 3D model I have imported. On the model I have a bunch of collision objects to stop player from falling down. I will show you their information but will not go into details because I have already explained them on previous tutorials, so you can watch the importing model and animation tutorial to get your 3D model to default, and watch 3D collisions tutorial to learn more about collisions. This is for the ground and these are for the boxes. And that's it. That's how you can create a first person controller with default. If you have any question, you can ask on the comment section. I will share this project file on my itch.io page, so you can go and download it from there. You can again find the link on the comment section. If you like the video, please like and subscribe. Thank you for watching and have a nice day.